In this next segment, we will move from discussing how some materials escaped Earth and come back to the escaping floodwaters of the Great Deep. Any theory of Earth's geology must explain the sedimentary layers found on the continents and on the ocean floors. What produced them? What was the mechanism? Uniformitarians say billions of years of weather, wind, erosion, coral formation, and ocean evaporation produced these sediments. Hydroplate theory's explanation of sediments is found in the materials of granite and the mantle floor that made up the subterranean chamber. The mechanism was the escaping high-pressure supercritical water, which easily ground and eroded the surfaces of the granite and mantle. So the fountains of the deep were full of tiny particles ground from these two surfaces. In addition to this grinding action, it is important to remember that the granite walls of the widening rupture were extremely unstable, since any rock below 5 miles was now unsupported and therefore was crushed, crumbled, pulverized, and ejected by the high-velocity upward flow. Of course, this was happening on both sides of the widening gap. This gap rapidly grew, putting great distance between the now separate sections of the plates which would eventually become the continents. As the lower structural support washed out, suddenly the upper rock had no support, so it sheared and slid down into the flow with the same pulverizing results. So this accounts for the erosion and particles, but what about the cementing agents? Remember that for centuries, the supercritical water had dissolved minerals from the walls of the chamber, precipitating a mushy blanket of minerals onto the chamber floor in a process called outsalting. So the escaping water swept up this loose mix of minerals, including limestone, silica, salt, dolomite, and other ores. At the surface, these minerals became the cementing agents that locked sedimentary particles together, forming the sedimentary rocks we know today. Once the eroded sediments and watery slurry of minerals was deposited in thick layers on the surface, the mixture was at low pressure, and as the temperature cooled, over time, after the flood, the minerals in the waters precipitated out of solution and readily locked the crystalline rock grains together, forming sedimentary rock. This is the only explanation which provides adequate reason for why such thick, vast layers spanning continents are found to be so consistent and remarkably pure throughout. All gradual processes involving millions of years fail to explain the thickness, purity, and consistency of these layers over vast expanses. So we've just explained how sedimentary rock was ground and cemented and why the layers are so pure. But what caused the vertical layers to form all at once? And why are they neatly stacked on top of each other with sharp, undisturbed boundaries and no signs of erosion? Biologic evolution heavily relies on the geologic column as evidence to justify the theory that life evolved over eons of assumed time. But if thick layers do represent vast ages of time, why are they not eroded due to exposure to weather? Is there a better explanation for how these layers formed? Are there other mechanisms that explain these layers? Geologists often scoff at a global flood, claiming there should be a layer in the geologic column containing all forms of flora and fauna if it were true. Since there is no such layer, they conclude a global flood is merely a myth. However, they fail to comprehend the true power and forces described in the Genesis account. Few understand the sorting capability of liquefaction. As we'll soon see, many overlook that the entire geologic column is the layer that they are looking for as evidence for the flood. So the no geologic evidence argument appears to be a case of missing the forest for the trees. Anytime objects fall through a liquid or liquid is forced up through objects, liquefaction can occur. The natural result of liquefaction is that it sorts materials according to size and shape. Assume all these objects were the same density. Their shape and size alone would cause them to come to rest in layers as a function of how fluids flow over their unique surfaces. If these same size and shape particles had different densities, however, they could sort much differently without respect to size or shape. Different combinations of these properties for each particle will give different layering sequences. Sharp, even layers can form as particles are sorted by the liquefaction process. As loose sediment particles were laid down in mineral-rich waters during the flood, liquefaction occurred on a global scale in several ways. First, sediments falling through floodwaters experienced initial sorting as we just discussed. In addition, the tidal pull of the moon was unimpeded during the flood, with no continental slopes to crash into, so tides rose and fell up to 200 feet twice a day. High tide forced water down into these loose sediments. Low tide allowed the water within the sediments to rise up through them, while again causing liquefaction and further sorting. Then, as high tide came, the sediments were again pushed back down as the water was forced through them. Realize too that heavy rain and sediments were continuously deposited over time. So as initially sorted layers were buried and protected, the tidal liquefaction process began again on the newly deposited sediments above. This time variable and the phenomena of lensing prevented absolute perfect sorting of the geologic layers by size and shape and density. Rather, patterns of sedimentation tended to repeat. Probably the biggest driver of liquefaction was occurring from forces below the layers as well. The up and down motion or flutter of the granite plates produced extreme wave heights and much liquefaction. Today, liquefaction is observed when only a portion of a continent moves slightly for just a few minutes during an earthquake. Now imagine the effect of an entire continent blanketed with loose watery sediments undulating for weeks. This movement arranged deep sediments more tightly, so the water in between again was forced up through the particles above. There was one other event during the flood which again produced mass liquefaction in the sediments. Hydroplate theory refers to this as the compression event. We'll cover this last liquefaction episode later when discussing the compression event. During liquefaction, another phenomenon is observed that should be realized. As differing sediments were sorted at different times, fine layers of clays and mats of uprooted vegetation were sorted within the layers and became trapped between layers of looser materials. As liquefaction cycles continued to occur, water from below ran into these fine, densely packed layers and retarded the flow up toward the surface. This produced pressure against the dense layer, which lifted all the layers above, producing water lenses within the layers. In this condition, water actually flowed uphill since pressures were lower upslope. Any low-density materials like vegetation or animal bodies were swept along these flows, producing coal seams, oil deposits, and many mixed fossil boneyards uncovered today. Just as particles were sorted by density, shape, and size, flora and fauna were also sorted. This is why so many of the same types of plants and animal fossils are found in the same layers worldwide. It is not evolution over time, it was the mechanism of liquefaction at work. This explains why some fossils are found in, quote, the wrong layers, and why polystrate fossils are found penetrating multiple layers that allegedly formed over millions of years. For one theory, these are expected results. For the other, they are a mystery and therefore must be ignored. In fact, you can see liquefaction and lensing for yourself by experiment. Get a couple of 2-liter plastic bottles and fix them to a teeter-totter arrangement. Fill one bottle halfway with any combination of mixed soil you wish and connect the hose between the bottles. Then add water to the other bottle and slowly tip them. After many back and forth cycles, layers and lensing will appear, until you have this. I saw water lensing between layers in this small-scale setup as well. So the next time anyone says the evidence of a global flood does not exist, consider that perhaps the evidence is all around us, including the dead things, called fossils, beneath our feet. Obviously, fossils can only form if the animals or plants are rapidly buried and preserved in sediments. In addition to explaining the origin of sediments themselves, the grinding away of sediments from under the plates produced another feature shared by all continents. Naturally, most material was removed near the nozzle area, where the velocities were the greatest. The flow acted like a belt sander under the plates, causing a gradual thinning and tapering of the plate perimeters for hundreds of miles. At the same time, as flow and sediments rocketed out from the base of the crack, it expanded and somewhat uniformly beveled the edges of the plates. This tapering and beveling is seen on all continents today as continental shelves and slopes. As plates were eroded, the crack widened and continued to do so until it was a gap hundreds of miles wide. As this happened, the explosive launching power of the fountains decreased, so heavy, constant global rain soon ceased. According to Genesis, the continuous heavy Geshem rain stopped after 40 days. Geshem is Hebrew, describing heavy, violent rain. Hydroplate theory sees the heavy rain as having a cause-effect relationship with the fountains of the deep. Notice the initial cause described in Genesis 7:11 was the bursting of the fountains. Then heavy rains are mentioned. In verse 12, we see that the rain was continuous day and night for 40 days, so this was not like the rain we know today. Later in Genesis 8 verse 2, again the fountains are listed first as closing and then the rains were restrained. However, if the escaping waters were coming from under the hydroplates, the rising floodwaters would have blanketed the fountains and stopped the rain, but the weight of the plates would have continued to push the remaining water and thick sediments out and up to the surface. This understanding would explain why Genesis records that the waters continued to increase and prevail on the earth for 110 days after the heavy rain had stopped falling. Think of the simplified scenario of a sprinkler placed in an empty swimming pool. Rain is the immediate effect of the fountains, which are the causal source. Constant rain will continue for a time until the sprinkler orifice is opened more, or the depth of the rising waters overwhelms the flow from the sprinkler, or the pressure in the hose drops, or a combination of all three scenarios. However, until the valve feeding the sprinkler is completely shut off, the water levels continue to increase, even though there is no rain. So at some point early on in the flood, jetting water stops producing continuous rain, yet water and thick sediments continue to flow out from under the plates. Why the fountain stopped was simply because as water escaped there was less room for the plate to flutter, and it sank closer to the mantle floor. No flutter meant a halt to the electrical and nuclear energy being generated, which powered the fountains. Of course, this also prevented water hammers from causing pressure spikes. Notice what happened to the balance of forces as the heavy granite was eroded. With hundreds of miles of material removed from each plate edge, the imbalance grew. Only the strength of the mantle floor was keeping the red force arrows from moving. Eventually, the imbalance overcame the rock floor's low tensile strength. The rock mantle suddenly and catastrophically failed, buckling and producing deep tension cracks as it arched and rose up almost 60 miles seeking a new hydrostatic equilibrium. In the field of engineering structures, buckling is a dangerous failure mechanism because it occurs suddenly, with almost no warning, releasing much pent-up strain energy very quickly. Let's examine two theories for the ridge's formation, plate tectonics and hydroplate theory. You decide which makes the most sense. Here we see the commonly taught concepts presented by the theory of plate tectonics. Plate tectonics proposes that the mid-ocean ridge is the result of seafloor spreading which causes plate movement, which is said to be driven by convection of the mantle. This spreading and convection concept are then used to explain the fit of the continents in the past and why they have slowly spread apart. If plates are spreading at the Mid-Oceanic ridge, then they also must eventually run into other plates somewhere. It is alleged that major mountains and ocean trenches are the result of these slow plate collisions. These thick tectonic plates are said to be subducting or diving under adjacent plates and then deep into the mantle below. These examples are animated and repeated as dogma so many times that few question if these concepts are physically possible. Mantle convection is usually compared to boiling water or gravy in a pot. This comparison completely ignores seismic observation that the mantle is a solid, with viscosity many orders of magnitude above that of any liquid, making the convection mechanism in solid rock highly questionable, and certainly it has never been demonstrated. The enormous forces and mechanisms required to produce mantle convection are vaguely described and then assumed to exist. Most explanation of plate tectonics is littered with much speculation, yet there's little supporting data. The mid-oceanic ridge is said to be the point where the new ocean floor is pushed up to the surface by these convection currents. This is attributed to deep liquid magma coming up from the mantle, expanding and pushing the plates apart. At first glance, this may seem plausible, especially when narrowly focused at the mid-ocean ridge. Now, while it is true that magma expands as it rises near the surface, one must consider how magma acts in all conditions before concluding that this is an adequate spreading mechanism. Graphics like this depict the mantle as if it may be all liquid or viscoelastic like firm hot putty, giving the impression that it could actually circulate as the arrows indicate. The reality is that thousands of seismic measurements repeatedly give the same picture. The 1,800-mile thick mantle is a solid, with some faults and fractures in it, which produce some liquid magma at times. Understanding this picture makes those convecting arrows seem a much less convincing conveyor mechanism. Now let's consider that magma, which convection is supposedly bringing up to the surface to cause seafloor spreading. Repeated experiments show that magma is a compressible fluid. So when all properties of magma under all conditions are considered, a huge physics barrier arises for proponents of any form of plate tectonics. Because of its compressibility, magma changes density depending upon pressure, which is based on its depth in the mantle. As stated, magma produced near the surface will expand and exert pressure. However, at only a depth of 220 miles, the pressures on magma are great enough to compress it to a density greater than the surrounding material. This is called the material's crossover density. The point at which a fluid reaches this density is called the crossover depth. Rather than rising up, magma created below this level will sink. The even greater depth means more pressure, compression, and higher density, a runaway process that hopelessly dooms the magma of any chance of ever reaching the Earth's surface. It should now be increasingly clear that the magma thought to be the mechanism in support of convection theories is actually their downfall. Looking at the crossover depth at a global scale, we see the immensity of the problem for any form of mantle convection. Only a small percentage of magma in the mantle will ever rise, while the vast majority of liquid magma generated in the mantle will compress to a density higher than the surrounding solid and will tend to drain into the Earth's liquid outer core, which is twice as dense as the solid mantle. Ideas that plumes of magma could ever rise from this dense core should be discarded. Convection of the mantle is not possible. In spite of this, magnetic reversals are often cited as irrefutable evidence for seafloor spreading theories. It is claimed that the crust contains a record of old versus new crust, spreading since magnetic, quote, reversals are seen in the ocean floor. These zones in the crust are where magnetic material supposedly shows that the Earth has reversed its magnetic poles many times in the past. So the floor is like a historical tape recorder of magnetic variations in time. This became popular when magnetic fluctuations were measured on research ships sailing over the ridge. Measurements showed high and low spots. A line was drawn through the data. Data above the line was said to be normal, indicating times of magnetic north. Data below the line was labeled a, quote, reversal, indicating time of magnetic south. Remember, hydroplate theory poses that the mantle suddenly bulged upward when the rupture widened by hundreds of miles. This produced deep tension cracks in the surface as it arched and stretched. Hydroplate theory offers a more plausible explanation of this magnetic data. There are no magnetic reversals, just fluctuations in magnetic intensity over the ridge. Magnetic materials, magnetite and hematite and basalt, lose their magnetism when temperature is above about 587 degrees Celsius. This is called the Curie point. Although not molten, the mantle's heat increases with depth. The deep tension cracks allow seawater to circulate and therefore cool more magnetic material per unit area near a crack. So areas near the deep cracks are more magnetic, while areas far from deep cracks are hotter and less magnetic. The result is magnetic fluctuations as one passes over the ridge's many deep tension cracks. Rarely presented is the fact that these same fluctuations are also measured as one moves parallel with the ridge. Remember, the ridge's cracks run both north-south and east-west. If you cut through the view of the ridge along this dotted line, we'd see this. The same magnetic fluctuations are measured. Why is mantle convection in this direction never proposed? So again, we see that when all the data is considered, seafloor spreading theory lacks consistent explanation, while hydroplate theory provides a straightforward and consistent explanation of what is observed that matches all of the data. The Mid-Oceanic ridge has unique repeated topography. It has a unique system of deep cracks. The largest and longest cracks always run perpendicular to the ridgeline. These are called fracture zones, which dominate the pattern. The crest of each section of the ridge is always bisected by a wide, deep crack that always runs parallel with the ridgeline, called an axial rift. Large axial rifts are flanked on either side by many adjacent small cracks called flank rifts. Rifts stop at fracture zones because the stress concentration at the tip of the propagating crack cannot pass through the rock that is not highly stretched. Notice how often rifts in one section of the ridge do not align with rifts in the next section of the ridge. Seafloor spreading proponents attempt to explain these features with a complex series of movements and shifts. All this shifting of sections back and forth is alleged to be occurring at the same time the seafloor is spreading away from the ridge in two directions. Hydroplate theory maintains that all these are simply deep tension cracks, and their unusual pattern is merely a record of a unique failure mechanism of the material which explains why the cracks are perpendicular and why fracture zones always dominate. When in bending, plates develop cracks that form parallel with the bending axis. As is commonly done when teaching material mechanics, I've illustrated this using foam to exaggerate the deflection and to aid in visualizing these concepts. I sliced the same piece of foam in two perpendicular directions. The two pictures are of the same piece of foam. As you can see, when bending occurs along a single axis, only one group of simulated cracks opens up in the foam. To get the tension cracks to open in two directions, the plate must experience bending in two axes. Here again is the same foam sample bent over an exercise ball, so when the spherical mantle foundation was exposed and sprang up, it buckled and stretched in two directions, which resulted in two perpendicular series of cracks forming almost simultaneously. I say almost simultaneously because the timing of the crack formation is the reason that the fracture zone cracks dominate, and why rift cracks cannot cross fracture zones. Fracture zones are not due to complex shifting of faults. They simply had a head start on the rift cracks as erosion of the granite plates progressed above. We've been following the balance of the blue versus the red force arrows in 2 dimensions. But consider what was happening in the 3rd dimension along the ridgeline. While there were a few unsupported forces perpendicular to the open crack, there were many more unsupported forces along the length of the crack. So well before the mantle ever arched up across the exposed crack, it first arched down the crack along the green arc. As this occurred, the mantle stretched and cracked in tension. These initial tension cracks always formed and grew first, and are what we see today as fracture zones. As the granite plates slid away from the rising bending mantle floor, axial rift cracks began to form along the ridge as it finally buckled, stretched, and failed in that direction. As the plates rapidly slid away, the rising ridge of the fracture zone cracks raced ahead and deepened. The mantle continued to stretch and new cracks formed along the ridge that were adjacent to the axial rifts. As axial and flank rifts ran into the deep fracture zone cracks that had already formed, they could not jump across the already deep and wide fractures. Precise measurements of the ocean's surface affirm hydroplate theory's idea that fracture zones are actually deep open tension cracks rather than shear planes along shifting faults. Sea level is not actually level because Earth's gravity is not the same in all locations. Large massive objects like island chains or the Mid-Oceanic ridge gravitationally pull the surrounding water up toward them. For example, the Hawaiian Islands raise the adjacent ocean levels 80 feet higher than they would be if those islands weren't there. Conversely, areas of the ocean floor that are missing mass, like trenches or deep, wide open tension cracks, will have a lower sea level than the denser surroundings. Because of this effect, fracture zones show up as areas where sea level is below normal. If fracture zones are just shearing faults rubbing against each other, then the sea level should be relatively level across the fault line because the mass, shown as M's in the picture, are uniformly distributed across the surface. However, areas along fracture zones register as areas of low sea level, meaning there is missing mass over the deep open cracks. Only a deep open crack explains this. You decide. To continue with the hydroplate theory overview, please click the following link to the next segment.